Hello guys, this is CodeNCode and this is the second lecture of the DP course part 2, and in this lecture we are going to solve this problem flowers taken from Codeforces, which is rated 1700 at Codeforces. So the problem is there is a guy, marmot I guess, so he eats flowers as dinner. So for the dinner to be tasty, there is a rule. So, there are only two kinds of flowers, red and white, and he eats flower in a sequence, so it would be like red, white, red, white, something like this. So a string of R and W. So he considers the dinner to be tasty if the number of white flowers are in multiple of k. They are in the group of k. So you are given A and B. We'll talk about this later, A and B. So basically you have to tell how many different tasty configurations are there for n size dinner. N size dinner means a string of length n filled with W, which is white flower, and R, which is red flower. So the restriction is only on number of white flowers, because number of white flowers should be in the multiple of k, because he eats a white flower in group of size k. So if I take an example and make this clear, so this is n and k, and this is q and k. Q number of queries 1 2 2 3 and 4 4, and I'll explain this later. K is equals to 2, so he would eat white flowers in the group of 2. So if n is equals to 1, that is length 1 dinner, so there will be two configurations, W or R. So R is valid because there is no restriction on number of R, but W is invalid because he would eat white flowers in multiple of 2. So 1 is not multiple of 2, that is why string W is invalid. So length 1, number of length 1 valid strings are 1 only, that is R. So number of valid strings of length 2 are 2, that is RR and WW. There are two more strings, RW and WR, but those are invalid. RW is invalid because R there is no problem, but W is only one time, which is not multiple of 2 again, and WR same for WR. So out of 4, only these two are valid configuration of length 2 strings. Now for length 3 string, these are the valid, and RRR, which is valid because no restriction on R. RWW, so he eats R, and then WW, these two are multiple. Of course, the consecutive, there are two consecutive whites which are multiple of 2, so this is valid. And then WW and R, so he would eat these two together because he eats in a group of 2, so he would eat these two together, and then this. So, for length 4, this is invalid one because he would eat two whites together, and then there would be left a single white. So he can't eat a single white because he needs a group, he needs to eat in a group of 2. So this one is actually invalid. So basically, if W appears, it have to be in multiple of k, otherwise it would be R. Either it should be multiple of W should be multiple of k consecutive W's. It is not like you fill one W here and then R and then another W. So that won't be considered as 2 because they must be consecutive. So W, if appears, should be consecutive W's. The number of consecutive W's must be multiple of k, and there is no problem with R. So yeah, we have seen for length 4 there are 5 valid strings, and now for queries it says 1 to 3, that is he would eat lunch of length 1 and length 2 and length 3. So what is the total number of valid strings of length 1 plus length 2 plus length 3? So the result is 6, because for length 1 there is 1 and then 2 and then 3, so the total sum comes out to be 6. 1 plus 2 plus 3, 6, that is why the answer is 6. For 2 to 3, length 2 valid strings are 2, and for length 3 valid strings are 3, so 2 plus 3 5, so the answer is 5. For 4 to 4, that is how many length 4 strings are there? Length 4 strings are, we haven't shown here, these are 5. So length 4 strings For n is equals to 4, that is for length 4 lunch and value of k is equals to 2. These are 5 valid configurations: white white red red, and red white white red, red red white white, and 4 times white and 4 times red. So these are 5 valid configuration. For n is equals to 5, these are 8 valid configurations where consecutive w's are appearing in multiple of k. So 4 times w and 2 times w, 2 times w. So now the question is, what restrictions do we have? First, each place of length n string would be filled by w or r. This doesn't seem like a restriction at all, of course, and that, yes, you are right. And for second restriction, of course, the number of consecutive w's must be multiple of k, right? So these are two restrictions. If you compare it with the previous problem, which was rated 1800, in that problem we were having 4 different restrictions, but in this problem we are only having 2 restrictions, one of which doesn't seem like a restriction. So let's start solving the problem. Okay, just a second. Okay. Let's start. So first of all, let me include one header file, and then this is for a reason. Now this should be visible, I guess. Now, so if you see, we have to solve this for a and b. Let me show you this. So we have to solve for all the n from a to b, right? We have to solve for 1, then for 2, for 3. For each test case we have to print the sum of number of valid string from a to b. And so for solution we are going to make a solution. So this get answer function only would return result for valid string of length n. So let for now take t test case n, a and b. So we'll read t and then a and b in sum is equals to 0, and then we'll run a loop. I is equals to a, I less than equals to b, and then I plus plus. I made a mistake here, this is b, and then each time sum plus equals get answer I. So finally sum would contain all the valid string of length from a to b, and finally we return sum. So this is how to solve the problem. So as you can see, the complexity won't be too good, but for now, as you remember, we don't think for any, when we start coding, we don't think of any restriction or anything. We just create a function, get answer. It would take integer input n would indicate which would indicate the total number. We have to return the total number of valid strings of length n. So if n is equals to 0, return 1. This is the base case. Otherwise, there are 2 questions that you should ask while writing down a recursive DP algorithm. First, what you can do, and second, can you do it? So first question is what we can do. We can fill the nth character either by w or by r, right? So this is the answer of your what you can do question. And the second question that you should ask yourself is, can you do this? So can you fill the current position with r? Initially we would think about, because this would lead us to the restriction. For now, just assume initialize answer to be 0, and then let's fill let's don't think of any restriction and simply just fill the current place with w. If you fill the current place with w, then you have to make decision for n minus 1 remaining characters. So we'll call the get answer function with n minus 1. Now if you fill the current place with r, then answer would be equal to get answer n minus 1, because current place you have filled with r, and you have to make decision for the remaining n minus 1 character. Finally you would return answer. But the problem here is, we know this solution that we have written is without any restriction, so solution won't be accurate. So it is not, I mean, there's no point testing this, running and testing whether what result we get, because we know the result won't be accurate. Now once we have written the algorithm, the recursive algorithm without any restriction, let's jump into the thing that I was telling you. So the first thing that we think, what we can do, we can fill the place either by w or by r. The second thing that you ask yourself is, can you do this? So to fill the current position with r, yes, you can do this because there is no restriction on r. But for w there is a restriction that w must be in multiple of k. So we need one more variable which would be k, and then after reading t, we are also given k in the test case. So if you see with t there is also k, so we, after taking t, we take input k. So if you fill the current position, suppose you have to fill position, let me take you this place. Suppose you are at the first position, and then suppose you have to fill the string of length 5. So you are for you n is equals to 5 currently, so you thought, okay, let's fill the current position with w. So if you fill for now, assume k is equals to 3, not 2. Okay, so if you fill the current position with w, can you fill the next two position with r? Just think about it. So for now k is equals to 3, not 2, for the thing that I'm taking you to think, asking you to think. For k is equals to 3, so if you fill the current position with w, this is the first position, so you fill the current position with w, can you fill the next two position with r? The answer is no, because that would lead to an invalid string. So what it tells you is that if you fill the current position with w, then the next k minus 1 position also you have to fill with w. So what it means that if you are filling the current if you want to fill the positions with w, then if you are on the nth place, then you would directly take k places and fill all those positions by w. So you are on the you have to make decision for 5, so you fill the 2 position with w, because you decided, okay, let's fill with w. So currently we are having k is equals to 3, so you fill the first place with w, and then the next 2 places also have to be filled by w. So now you won't be left with n minus 1, because if you are filling the current position with w, you have to fill the next k minus 1 position also with w. So you won't be left with n minus 1, you would be left with n minus k, because out of n, k position you are using to fill w. That is why for w, if you are filling the current position with w, then you are going to use the next k position for w, otherwise the string won't be what we call it, valid string. So if you filling if you want to fill it with r, no problem, fill the current position with r. Now you are left with n minus 1 characters to choose to make decision what we should fill for those. But if you are filling the current position with w, then you have to fill the next k minus 1 position also with w, which would leave you with n minus k characters, not with n minus 1. So that is why the next recursive call would be n minus k. And to make this, the question is, can you do this? The answer of this is yes, if n is greater than equal to k. Suppose k was 3 and you have to fill the strings you have to return n is currently 2, so you can't fill 3 position if you have only 2. That is why n have to be greater than equal to k, and that's why you would check whether you can do this or not by this condition. If you can, then you would do this like this. And since these were the only two restrictions that we had, so finally this would be our result. We have to do nothing more. We could fill the first position with either we could fill the nth position with either w or r. If you are filling with r, no problem, fill it, then you would be left with n minus 1. But if you are filling the position with w, then you can't simply fill the current position and leave the n minus 1 character to be filled either by w or r. You know that if you fill the current position with w, then the remaining k minus 1 position also have to be filled by w. So instead of n minus 1, you instead of filling one character, you would fill directly k characters, and then you would be left with n minus k characters to make decision for. So after doing this, I think our algorithm is completed, because we only were having two restrictions. What is the name of it? Oh, flowers. So since we have completed our we have applied both the restrictions, so this should be giving us the required answer. So let's go here. This is the problem. Flowers rated 1700. So this is the test case, if you can see. So there are like 3 test cases. K is equals to 2. First test case is 1 and 3. The answer is 6, as you can see. Output is 6. And then second test case is 2 and 3. The answer is 5. In the input, answer is 5. Sorry, in the output, expected output was also 5. And 4 answer is coming out to be 5, which indicates the solution is good. But the problem is, if for each test case you are going to run a loop and each time calculate this is going to cause a problem, because each time if you go from L to R, of course after t test cases the algorithm would run into t into n time, because a and b can be as large as n itself. A can be 1 and b can be n. Each time you are going to run a loop n times, so t into n would be the running time, which is not sufficient to pass the test cases. So we have to give answer of this in linear time. So what we can do, we can of course pre-process it. We can create an init function, that is to initialize it, and we can create a prefix sum function to output the result of each. Suppose we have a prefix function. Let me create the array, prefix array here. Prefix of 10 to the power 5, size 10 to the power 5, because in the input a and b can be as large as 10 to the power 5. So that is why I've created an array prefix of size 10 to the power 5. Let us take it as long int instead of int. And now let's create the prefix array. So after we have prefix array, what we can do, we can simply the sum would be prefix of b minus prefix of a. This would be our result, and this can be calculated in constant time instead of doing this, and each time in constant time we can return the result. So how we void init function, which is actually to initialize. For init function we must pass a and b can be 10 to the power 5, so we must initialize it for 10 to the power 5. So for I is equals to 1, I less than equals to 10 to the power 5, I plus plus. How you define prefix array, since you are I'm assuming that you know how we initialize prefix array. So prefix of I is equals to prefix of I minus 1 plus solution of current, solution of I, prefix of I. So solution of current is get answer current. Answer of I is equals to get answer. So after this prefix array would be built. To give your answer, you would be you can calculate the answer in constant time. Now there is still a problem, I'll be talking about that, but first let's test whether the solution is correct or not. So 3 2, oh yeah, since we are running a loop till 10 raised to power 5 and we haven't converted this to a DP solution, because to convert it to DP solution, long int DP. Now to convert it to DP solution, what we do, if you remember from previous lecture, we check whether DP of n is not equal to -1, which indicates we have been to this state earlier, so we would directly return from here DP of n is equals to, return DP of n. Otherwise we would proceed to calculate the result, so we are calculating the result till here and then return DP of n is equals to this. So before returning, we are updating the DP table. So before we can make any get answer function call, we must initialize our DP table. I is equals to 1, I less than equals to 10 to the power 5, I plus plus DP of I is equals to -1. So we are initializing the DP table. After that, this solution is turned into DP solution, and because of these two lines, first we are checking before making any recursive calls, we are checking whether we have been to this state or not. If we have been, then DP of n won't be -1 and then we would return directly. Otherwise we are calculating the result and then we are returning, we are saving it so that we can directly use it in other test cases. So this would run in constant time. What would happen, first you would make a get answer call to 1. So once you reach here, let me just do this. So when n is equals to 1, you won't nk is equals to 2, so you won't make this call, you would directly make this call. So you initialize 0 as well. So DP of 0, you don't have to initialize DP of 0. DP of 1 would be saved while you would be returning from here. So DP of 1 would be saved, and then you would make a get answer call to 2. Now 2 would make 2 calls. One call would be to DP of one call would be to get answer 1 and one call would be get answer 0. Both would be returning in constant time, because get answer 1 would return answer directly from DP of 1 and get answer 0 would return answer from here. So both would return in constant time. So if you make a get answer call from here to say 100, what would happen? 100 would make two calls, two recursive calls. It would, when n is equals to 100, it would make two recursive calls. First call would be get answer 99. First call would be this, so it would be get answer 98. But since we are on 100, so we might have already, in fact we have 100% sure that we have already calculated all the values till 99. That's how we are on 100, right? Since we are on 100, so we have already calculated result get answer on from 1 to 99. So the DP array contains solution of all get answer from 1 to 99. So when get answer 100 is called, it would make two calls, one to get answer 98 and another to get answer 99. And get answer 98 and get answer 99 are both already calculated, so these two would be returned in constant time. So get answer is actually being calculated in constant time. So the prefix array of 10 to the power 5 would be calculated in big O of n time. So pre-processing is taking big O of n time, where n is 10 to the power 5, and then after that we are returning, we are calculating result of each test case in constant time. So the overall complexity is big O of n plus t. So let's run this and see if we get any error. So there are no errors. Let's run for this test case. So this is 3 2 1 3, answer is 5 1 2 3, the answer, oh yeah, is actually this. When you want to calculate the result from L to R, you take the prefix sum till R and then subtract L minus 1, prefix sum of L minus 1. So that was a mistake, and now let's run. So 3 2 1 3, result is 6, which is good. 2 3, which is again correct, and then 4 4, the result is 5, which is again correct. So our DP solution is working. The final thing to update here is that we have to take it modulo 10 power 9 plus 7, because in the problem it is said that we have to take it modulo 10 power 9 plus 7. So I have already defined mod to be 10 power 9 plus 7, and in each state, if we are calculating, answer is equals to answer is plus equals get answer. So after that you have to mod answer. So answer is equals to answer modulo mod, which is 10 power 9 plus 7. So after calculating this, you would perform a modulo operation, and so is here answer is equals to answer modulo mod. Finally you are returning answer. But the problem here is that when you in modulo arithmetic, when you are taking difference of two numbers, then this result can also be negative. So this number can also be negative. To counter that part, you add modulo and then finally take modulo. This would be the final solution, and I'll explain why that can be negative. The last time we are testing it, so 1 2 3, answer is 6, 2 2 3, answer is 5, 4 2 4, answer is 5, which is correct. Now the question is why I am adding mod and then taking modulo. See, I said that when you in modular arithmetic, if you are taking we are subtracting two numbers, then the result can be negative because of this fact. Sorry, this was for restriction for this. So this is Fibonacci series, and we have to return difference of A and B modulo mod. So A fib of A minus fib of B. So A would be greater. We know that if you subtract a smaller Fibonacci number from higher Fibonacci number, it won't be negative. So fib of 5 minus fib of 4 won't be negative, right? So it is 2. But Fibonacci number that we have written here are not taken modulo 4 already. These are there in their actual form, but here what we are doing, prefix array is actually, the problem is here, after calculating prefix array, you have to take modulo of it. Perform modulo prefix of I is equals to prefix of I modulo mod, because it can go out of bound. So it is important each time after calculating prefix array you take its modulo, otherwise it would go out of bound of integer or long int. So what we are doing here is that we each time after calculating prefix array we are taking it modulo mod. So if you see here, the numbers are increasing order, in increasing order, because Fibonacci number is sum of previous two terms. Since previous two terms are positive, the sum would be in increasing order. So if you subtract fib of A minus fib of B, where A is greater than B always, so the result would be positive, right? But if we write the Fibonacci number modulo 4 already, so 1 modulo 4 is 1, 1 modulo 4 is 1, 1 plus 1 2, 2 modulo 4 is 2, 2 plus 1 is 3, 3 modulo 4 is 3, and 2 and 3 is 5, 5 modulo 4 is 1, and 4 3 plus 1 is 4, 4 modulo 4 is 0, and so on. So we have already taken modulo. Now you see, this series won't be in increasing order anymore. This even though the original series is in increasing order, but if you perform modulo operation, then it is not necessary that the series will be in increasing order. So if you subtract it, this may result into a negative number. So you see, fib 5 minus fib 4 now results into a negative number, because 1 minus 3 is minus 2, and minus 2 modulo 4 in C++, in most of the programming language, would be minus 2. and the judge doesn't expects a negative number as a result. It expects a positive number, because modulo 4 result should contain result from 0 to 3. So to convert it into a valid solution, you have to add 4 and then take modulo. So minus 2 plus 4 would be 2, and 2 modulo 4 is 2. And if the result was already positive, like 3, if the difference of two number was 3, 3 plus 4 would be 7, 3 plus 4 would be 7, and 7 modulo 4 is again 3. So if the number was already positive, adding modulo into it won't change anything. So if the difference of prefixes was already positive, adding modulo won't affect the result. If this was negative, it would be converted into a positive number. That is why it is important to, if you are taking difference in modulo arithmetic, add modulo and then take modulo finally. So this should be good, and we would finally submit it. It was important to tell you about these things because there are cases when people think what went wrong while submitting, and they have no idea that in modular arithmetic there may be negative solution. Even the increasing I have to remove this. Even the increasing sequence can be negative. So that is why, let's remove the final thing. Okay, it was important to explain. Let's submit this. Hope we don't get any error. Okay, it is running on. So we get an AC. So here we have submitted the solution for flowers and we get an AC. So this was all for this problem. I know this have been this solution have been a longer than I expected, so sorry for that, but there were some things that I thought that are important to explain you guys like this. So sorry for being this explanation being longer, and thank you guys for watching, and I hope you have learned something from it. Thank you guys for watching, and yep, till the next video drops, keep coding. Thank you.